Hello friends, welcome back to your favorite channel Code One Digest. In this video, we will cover the factory design pattern. This is also a type of creational pattern. I will show you the use case of this pattern, a code snippet to implement this pattern, and at the end, we will also discuss the benefit of this pattern. Friends, we have already covered builder pattern in previous video. Can you explain the use case of builder pattern? Please reply in the comment section with your answer. You have not seen the previous video of builder pattern, so please go and watch that video. Link is provided in the description here. Just to summarize, the builder pattern is the construction of complex object using simple object. For more detail, go check it out the previous video. Okay, so let's begin with the factory pattern. A factory pattern is a pattern that provides an instance of one of the several possible classes based on provided input. This is a very common pattern in object-oriented programming language. Usually, all of the classes it returns have a common parent class and common method, but each of them perform different tasks and is optimized for different kinds of data. Let's see an example of factory pattern. Here, client wants different type of invoices to be created. Here, invoice objects are instantiated by a factory class for a given input. So you can see this is a responsibility of factory pattern to instantiate an object of desired class based on the provided input. Let's understand what are the issues we have with the traditional way of objects creation. Why do we need a factory pattern class to instantiate instances of different types? Why can't we use traditional ways to create object of different types? There are two issues with the traditional way of objects creation. Let's take an example. Assume you want to create libraries and you have a client who consume these libraries to build their application. So the first issue arises. Client code will have lots of new keywords to create objects of different types. Second, the client code is loaded with lots of object creational activities, which can make the client logic very complicated. The third issue is the client needs to be aware of all types of classes available in your library for object creation. So if we use traditional way to create objects and if we add a new class to the library, then client code need to be changed to use this new class and client code need to be recompiled. But if we use factory pattern to create instances of desired type, then client code need not to be changed. I have prepared a code snippet for the factory pattern. Let's see how to implement and use the factory pattern in our code. I will run this code and show you the output. This is an example of product factory. In this example, we are using product factory class to create different types of product objects. Product A class using the out of the box method of superclass, whereas product B overrides the method to customize the output, and factory class is used to create the instance of different product type. This way, factory class instantiates different types of object based on the inputs provided. But things to remember here is all different types of product classes having the same parent class. So here we have a product abstract class, and then we have a product A extending product class, but doesn't have any method. It is using the default implementation of superclass. Product B is also extending the product class, but it has its own implementation of write method. We have product factory class. Here we have created a method which takes input, and based on the input it is initializing instantiating the object of a product. Now, I have written a factory pattern test class. In this test class, we'll be testing that based on provided input, we are creating the instance of product A and product B. So here you can see while creating the product A, it is using the default method from abstract class. But while creating the product B, it is calling the method from a product B class. But factory class is successfully able to create instances of different product types. Let's understand where to use factory patterns. Whenever we have a class that can't anticipate the type of object it must create, that time we can use factory pattern. Whenever you want to be aware of which class is getting created, that time you can use factory pattern. Whenever you want to insulate the client from the actual type that is being instantiated, you can use factory pattern. Let's see the benefit of factory pattern. The client does not need to know every subclass of objects in library. It only needs reference of abstract class and the factory class. Factory pattern encapsulates the creation of objects. This can be useful if the creation process is very complex. Okay, let me summarize this video now. So in this video, we understood what is factory pattern. We saw the use cases of factory pattern. We also saw how to implement and use factory pattern in our code. At the end, we also covered the usage and benefits of factory pattern. Please let me know if you have already used factory pattern in your code or project or encountered a situation where this factory pattern can be very useful. Please provide information in the comment section. In next video, I will cover prototype pattern. We will see what is prototype pattern. We will learn the usage of prototype pattern. We will see the implementation of prototype pattern and see the benefits of this prototype pattern. So stay tuned for the next video and do not forget to subscribe this channel. Kindly like, share this video. This is very useful information for the beginners and software engineers. Please click on the bell icon for the latest video notification and subscribe to this channel for more technology related videos. Thank you.